Topic 2A, graphical summaries for qualitative data. Okay, so we talked about the difference between qualitative data and quantitative data. Qualitative data is categorical, characteristics, qualities. So it's the non-numerical data. So what we're going to look at today is graphical summaries for them. We're actually going to start with frequency distributions. Now, a frequency distribution is just where we show the different categories or qualities and how many times they occur, the frequency, number of occurrences. So let's look today at hair color. So let's label this as frequency distribution so we're familiar with what it is. So if we look back later, we don't get confused. Right, so let's say I want to ask a class and find out how many people have which hair color. So I'm going to put hair color here. And then let's say we have black, brown, blue, blonde, and other. Now you can see I was kind of following the alliterative trend, black, brown, blue, blonde, and then I put other in there. Whenever you're dealing with categories and they're not restricted to just a certain number of them, meaning that you can have certain things, like if I'm talking about letter grades for people who complete a course, then the only possible categories are A, B, C, D, F. So there's no need to put other in there. But when we're talking about different things such as car manufacturers, I could list off a bunch of car manufacturers, but there are others that are not part of that grouping. So we like to put other as one of our categories, kind of as a catch-all, to make sure that we get everybody. So what I'm going to do here is I'm going to use what I call a helper column, and I'm going to put a tally. So this is a helper column. So I put that in black to show that that's not really part of the frequency distribution. It's just a column that we put there to assist as we take our data. So what I'm going to do is, as we go through this, I'm just going to ask people what their hair color are, and they're going to respond. You're not going to hear me ask, you're not going to hear me respond, I'm just going to write them down. And this tally column allows me to write them down as they come. I really have two options of how I can find out how many people have brown hair or how many have blonde hair. I could either say, if you have blonde hair, raise your hand, and when they raise their hand, I count the number of hands. Or I can go person by person and say, what color is your hair? And then I mark it down as a tally mark so that that will then get marked on here, and then I can count up those tally marks. Now you may wonder why, if I have the ability to do just have people raise their hand and get an answer, why would I do tally marks? Well, the reality of it is, remember that we had the non-response bias, people who choose not to respond? Well, that's what happens in a classroom. If I just tell people to raise their hand if they have this color or that color and such, I end up with people who don't raise their hand. When I go one person by one person, then they do tell me the color and I'm able to mark it down so I get everybody involved. The other reason you may do things like this is, let's say you got in a whole bunch of surveys. You got 1,000 surveys, and you need to find out how many people had black hair, brown hair, blue hair, etc. Well then, what's going to work best is to go through and, instead of counting, going through and saying, okay, that one had blonde, that one had blonde, that one had blonde, that one had blonde, somebody comes in and interrupts you, like, oh, what was my count at? It works much better. You can go through just once and mark down all the tallies. And if you get interrupted, that's okay. You're at this survey, okay, mark down the next one. So it can make it much easier for us at times to use this tally or helper column. So I go through and people start telling me what color hair they have, and I start marking it down. And I keep going. And then I'm done. And so I have everybody marked down. Oh, there was one more. There we go. Sorry, I forgot that one person. So now I've tallied up, I've got these marks, and I'm going to now do a frequency column. Frequency. Now, many times we abbreviate frequency. We may write it as just FREQ. Sometimes we get so lazy as to just write F. In fact, you will see me do that a lot. I like to just use F for frequency. Anything that saves me writing is a good thing in my book. So now I'm going to just count the tally marks. And since I put them into groupings of 5, it's pretty simple to see that I've got 7 people with black hair, 14 people with brown hair, 1 person with blue hair, 4 people with blonde hair, and 2 people with some other color. So this right here is a frequency distribution. It's just a listing of the categories and a count of how many occurrences there were in each of those categories. Remember this column in black, the tally column? That's just a helper column, so you do not need to include that when you are making a frequency distribution. That's just there to assist us along the way if we feel we need it. So that's a frequency distribution. Well, that's good. That gives us the counts, right? And we can even take this frequency column here and, oh, what's this? That's a summation symbol. Some of you may be familiar with this capital Greek letter sigma, which in mathematics means summation. Well, when I write summation, that tends to look a lot more like that. So that's summation. It just means add up. And when we're dealing with tables and such, we're going to be dealing with summing up columns all the time. So you're going to see this summation symbol a lot. We're going to do a lot of summing. So we've got this frequency column here. And if we add up all the values in this frequency, 7 plus 14 is 21, plus 1 is 22, plus 4 is 26, plus 2 is 28. So we have a total of 28. And we can say that 28 is equal to n. Now n stands for sample size, and lowercase n, let me specify, is the sample size. So lowercase n is equal to the sample size, and we will be using it as such throughout the course. So we have a total of 28 students who responded to this, so that was my sample size of 28. And that was the summation of that column. So now we've got that, and that's great to have this information about how many people had brown hair. 14. How many people had blonde hair? 4. How many people were surveyed total? 28. So that works very nicely. Sometimes we want a little more information than that, though. Instead of just wanting to know how many people had each thing, because let's take a little step aside from this and say, what if you did not have this information? It's not here. You do not see it, right? What if this information was in here and I just told you that I took a survey and 7 people had black hair? then the question is 7 people having black hair a lot or a small amount? Well, wouldn't that depend on something? If I had a survey of 1,000 people and 7 people had black hair, that's not a lot of people with black hair. But if I have a survey of 10 people and 7 have black hair, then that's a lot of people with black hair. So really, we can get more information from a comparison of the frequencies and the sample size. How many people were involved in that? So what we're going to do is we're going to get rid of this summation symbol over here, and we're going to add another column. And that column is going to be the relative frequency. Relative frequency, meaning that we are going to relate that frequency to the total number of people involved, or the sample size. So the relative frequency is actually the frequency of a certain category divided by the sample size n. So relative frequency is just that ratio of the frequency to the sample size. So let's find the relative frequencies. Well, as a fraction, we have 7 out of 28, 14 out of 28, 1 out of 28, 4 out of 28, and 2 out of 28. So those are our relative frequencies. Well, if you're going to leave the relative frequency as a fraction, at minimum, you need to simplify the fraction. 7/28 can be reduced to 1/4. 14/28 can be reduced to 1/2. 1/28, that stays as it is. 4/28, 1/7. 2/28, 1/14. So now I've simplified or reduced those fractions, and that's good. So we know the relative frequencies. Well, remember I said that we like to add up these columns, so I'm going to add up the relative frequencies, and we notice that 7/28 plus 14/28 plus 1/28 plus 4/28 plus 2/28 equals 1. So our relative frequency column should always add up to 1. That doesn't mean that we should just ignore the adding because it's always going to add up to 1. That's a sanity check. We add up this column, and if we get 1, then we trust what we did to get there. If we don't get 1, then we look and see if maybe we made a mistake. I've had students come to me and ask me, I can't figure out what's going on. What happened? Why didn't my number come out right? And it turns out when they summed up their frequencies to get their sample size, they came out with the wrong number. So then, when they did their relative frequencies, it didn't add up to 1. And they never did that check. So whereas they should have had a total of 28, they had it as 26. So when it added up, it actually came out to be 28/26, but over 1. And with that, if they had done that summing up correctly, they would have seen there was a problem. But of course, that threw everything else off as they were working their way through it. So that's our relative frequencies, but some of us may not want to deal with fractions, and some of the things we're going to need to do, we don't want to deal with fractions. So let me just get this f over n out of the way, but I'm going to take my relative frequencies to a decimal. Now, I have a tendency when I take them to a decimal, I like to see 2 decimal places. It's usually the best setup to go out to 2 decimal places. Going 3 decimal places never hurts anything, but when you go to only 1 decimal place, you tend to run into problems. So 1/4 is 0.25, 1/2 is 0.50, and now I'm going to grab my calculator and cheat, and we got 1/28 is 0.04, 1/7 gives me a 6-digit repeating decimal. Well, we'll call it approximately 0.14, and then 1/14, 0.07. So I have my relative frequencies as decimals. Now when we convert our relative frequencies to decimals, you notice that I had to round some of those. This was rounded, that was rounded, that was rounded, right? So I had to do some rounding here. So what this may do is it may cause us a problem when we add them up, where it doesn't add up to exactly 1. In this case, we don't have that problem. This does still add up to 1, and we're fine. If it doesn't add up to 1 because of our rounding, it may be off by a little bit. I rounded to 2 decimal places, so maybe I'm off and I get 1.01 or 0.99 or 0.98, right? If I'm off by a little bit because of rounding, that's okay. In this particular case, it turned out to be 1, so I'm really happy. But we are looking for this to be 1, if we're dealing with the fractions, or if we're dealing with the decimals, to be 1 or darn close to it. So those are our relative frequencies. Well, I'm going to add another column here, and hopefully we're going to have the space, and I'm going to find percents. Percents is always a good thing to have. So percent. Now, if you remember, how do you find a percent? From a decimal, you just move the decimal point over 2 places to the right. So our percent is going to come from this relative frequency. The relative frequencies are really the proportion of the people involved who did a certain thing. So we're just going to turn these into percents by multiplying each of these decimals by 100. So we get 25%, 50%, 4%, 14%, and 7%. And then because we add things up, we're going to add that up, and amazingly enough, in this particular case, we get 100%. Now, please keep in mind that if our relative frequency from adding up the decimals had not come out to be exactly 1, then our percentages would not add up to exactly 100. So if we had 1.01 here because of rounding, we would have 101%. Now, for the purposes of what we are doing, that is perfectly fine. You don't have to take it out more decimal places so you can get it to be at exactly 100%. So we're good with that. And just remember that percent was the relative frequency, RF for relative frequency, times 100. So that's what we did. We took this column and multiplied it by 100, and that's where we got our percents. The last thing I'm going to do with this is I'm going to put one more column here, and I'm going to call it degrees. Just barely fit that in there. So degrees, we're going to do a couple different types of graphs here. We're going to deal with bar graphs, and we're going to deal with pie charts. When we deal with pie charts, we want to know degrees. We want to know how we're going to break up that circle of a pie chart. So how many degrees are there in a circle? 360. So our degrees is going to be relative frequency times 360. So we're going to take the proportion of the 360 degrees of a circle to get our relative frequency. So 0.25 times 360 is 90. So 90 degrees. 0.50 times 360, 180 degrees. 0.04 times 360 gives us 14.4 degrees. 0.14 times 360 gives us 50.4 degrees, and 0.07 times 360 gives us 25.2. Now again, if we had to round our relative frequencies, the decimals, then that could affect the sum of our degrees. If we add this up, because it worked out to be exactly 1, turned out to be exactly 100, this will turn out to be 360 degrees, and we can see that it does. So we come out with 360 degrees, which is great. I'm very happy with that. So now we have all the information that we need to be able to put together some graphs. And tune in for the next video when I will put those graphs together.